A project like this requires a lot of specialists. The companies of Balfour Beatty and Kumler and Matter were able to find those specialists in Germany, Austria and Switzerland. The plant is designed to last for 40 years, so quality is our top priority. Planning began in 2008. This phase is completed, and now we can begin. The Gotthard Massif. For centuries it has been a natural barrier between northern and southern Europe, but not for much longer. In future, the journey from the north to the south side of the Alps will take just 2 hours and 40 minutes. The Gotthard Base Tunnel is part of the new Alpentransversale railway, which will cut a whole hour off the journey time from Zurich to Milan. For trains with speeds up to 250 km an hour, the construction work requires absolute precision. The engineers have to install the overhead contact lines into the 57-kilometre-long single-track tunnel tubes. Perfect logistics are essential here, as are closely knit safety precautions when working beneath 2,500 metres of rock. The employees at the control centre can detect the location of each fitter and each vehicle in the tunnel, while cameras secure the tunnel entrance portals. A further important contribution to work safety is the intensive training the workers have to undergo. It applies to every single move they make. When working in the tunnel, precision is required from the very first drill hole on. The concrete tunnel vault provides a secure area for fixing. The powerful forces created during high-speed operation are absorbed by these reinforcements. All 40,000 fixings are individually tested for 3 minutes each, and each has to withstand a force of around 7 kilonewtons. All the components in the tunnel have to be earthed. Here, the low platform of the construction train makes the work safe and efficient, because it can be reached from the platform. Engineers and specialists are developing special supporting structures for the Gotthard Base Tunnel. In the lab, the prototypes of the suspension hangars undergo corrosion tests and X-ray examinations until they are optimized and the Federal Transport Office has approved installation. For this project, it's very important that we have precise planning. The plan is drawn up here in the project office in Zurich by our specialists from the headquarters of Balfour Beatty and Kumler and Matter. If you unpacked all our planning documents and placed them end to end, you'd cover an area the size of roughly 3 football fields. The reason is because the basic design is very detailed and comprehensive. The preparations for the years of work in the world's longest rail tunnel are the exclusive task of specialists. The development teams in Zurich accompany and supervise the project. This is where engineering expertise for a once-in-a-lifetime project originates. One globally unique solution is the construction train. Especially for this project, we designed a construction train, enabling us to enter the tunnel with various different formations, so we could save valuable assembly time. Each wagon built at the plant in Gotthard was custom designed. For the overhead contact lines to be installed safely and economically in each of the 57-kilometre-long tunnel tubes, the work requires millimetric precision. The construction train has to be precisely steered as it makes its long trip to the construction site inside the tunnel on a daily basis. We enter the tunnel at a speed of 80 km an hour. At the site, we divide the construction train into 3 sections. These work formations are self-propelled, that is, they can handle their assembly work independently. At the end of the shift, the entire construction train is joined up again, and then the convoy returns to the installation site. Installing two 57-kilometre-long overhead contact lines in tunnel tubes which are only single track is an operation that demands a great deal of expertise, plus perfect logistics at the installation site. All components are pre-assembled as far as possible. The buildings and halls contain automated workstations, the logistics centre and the materials store. Every component needed for installation in the tunnel, however large or small, passes through here. Altogether, the fitters drill over 40,000 holes for the fixings, mount 2,700 catenary supports and 2,750 feeder supports, and travel tens of thousands of kilometres to and from the installation site, using the construction train specially designed by Balfour Beatty and Kumlo and Matter. The equipment on the train also enables the men to carry out all the work in the tunnel safely and quickly. The forklift truck is secured against slippage and has a special mechanism allowing it to reach the components without shunting and to transfer them to the fitters on the platform with great precision. High-powered magnets bear the weight of the 150-kilo suspension hangers until they've been securely fixed in position. The suspension hangers mustn't project into the vehicle profile. That's extremely important, because otherwise the vehicles might be damaged. The electrical conductors are bare. Later, the overhead contact line will have a charge of roughly 15 kilovolts, and it needs a certain insulation layer. Our insulating material is the air, directly against the vault of the tunnel. So that's why we have to keep to the 25 centimeters. The teams have to maintain safety distances and install all the components within the tightest of spaces. That includes the so-called radio or leak cable, an intentionally leaky cable that has the properties of an antenna and transmits radio signals to the train. A further challenge when designing overhead contact lines, keeping as great a distance as possible between the contact line and the catenary wire located above it, to avoid any damage in the case of a short circuit. At the same time, a safety distance from the tunnel roof of 25 centimeters has to be maintained. The solution are these brackets, screwed onto the suspension hangers. Here, insulators with a fiberglass reinforced core and silicone lamellae ensure that no flashovers occur. The assembly teams are making good progress because nearly every trip and every move was simulated in the planning beforehand. In regular operation inside the Gotthard base tunnel at 250 km per hour, the height of the contact wire must never deviate from its precise distance of 5 meters 20. This is why the catenary system is tensioned with weights, 17 kilonewtons for the contact wire and 15 kilonewtons for the catenary wire. To test the system's load-bearing capacity, test trips at up to 275 km an hour are carried out. This places the highest demands on all components used as well as on their quality. With the help of a die, a groove is drawn in the untreated wire made from a silver-bearing copper alloy. A purely mechanical operation, transforming the relatively soft copper into a contact wire. On another production line, the catenary wire is being created inside the stranding machine. Lab tests ensure that all requirements placed on conductivity and stability are fulfilled. The contact wire and the catenary wire are now ready for installation. The fitters in the Gotthard base tunnel will be using a total of 1,400 tons of copper. New safety concepts, safe design and safe construction processes all support them here, with the result that every single man returns safe and sound from the tunnel every evening. The technical equipment on the construction train also plays a role here. This morning it is entering the tunnel in its longest and most elaborate formation yet. To allow several locomotives to use the 57 kilometers, 4 line feeders supply the contact wire with the necessary power. Even though the assembly work seems rough, the contact wire has to be finally positioned with absolute precision. The units travel in a convoy along the routes to the site at a speed of 80 kilometers per hour. Depending on the task, the train has several different formations, thus saving on valuable assembly time. The contact wire is now hanging in position, and so is the catenary wire. This is the crucial moment. The line is slackened and the weights do their work. Right now we're at the cable pull stage. In other words, the contact wire, catenary wire, feed conductor and earth conductor are currently being pulled into the tunnel. For the contact wire, it's very important that its final position is absolutely precise, so that the trains can travel through the tunnel later on at 250 kilometers an hour with a high-quality power supply. During this work, in the most cramped of spaces, the engineers utilized the globally unique possibilities of the construction train. Mounting of the return conductors goes smoothly. Depending on the work step, the fitters move special mini platforms out to the sides so that they can work safely and quickly. The self-propelled rail wagon with lifting platforms, developed by Balfour Beatty and Kumla Unmatter, has an electromechanical drive, enabling the men to approach each work position with millimetric precision. This is a basic prerequisite for perfect installation of the suspension hangers. The fitters and engineers know they can rely on everyone else in their teams. Planning and implementation are rolled into one.
Fahrleitung ist geerdet, mit den Arbeiten können begonnen werden.
Wir müssen im Prinzip nachweisen, dass die Test and Commissioning demonstrates that all technical and project requirements are working as developed during the concept and design stages. It ensures that interfaces between different and existing systems, as well as third-party systems, are integrated and systematically closed. The testing and commissioning phase is very important. This series of activities is necessary in the construction of a high-speed railway system before it can be safely opened for the commercial operation in the year 2016.